My name is Abba Lippuner, and I'm at the University of Kansas Medical Center. A is for alpha particle. An alpha particle is simply two neutrons and two protons tightly bound together. It is essentially a helium atom, but without the electrons. Alpha particles usually come from the decay of radioactive materials, such as uranium or radium, to name a few. Alpha particles are very destructive to human cells, but fortunately lose their energy quickly. Just a few inches of air or a single sheet of paper can shield you from alpha radiation. There are many uses of alpha particles, from the powering of Mars rovers and in the design of smoke detectors. Alpha particles are also used in cancer treatment. The advantage in using them to treat cancer is that they don't travel far and are therefore effective at sparing normal tissue and focusing mainly on the area of the body being treated.
My name is Dan Scanderbeg, and I'm at the University of California, San Diego. B is for brachytherapy. Brachytherapy is a type of treatment where small radioactive sources are placed inside or next to a patient's body, usually to treat cancer. Brachytherapy sources are usually small pellets or ribbons of radioactive metal, though in some cases, very small electronic X-ray devices may be used. Brachytherapy has been shown to be a very effective type of radiation therapy and has been used to treat many different types of cancers. These include lung, breast, esophagus, prostate, gynecologic, eye, and skin cancers. Sometimes the brachytherapy source is permanently implanted in the patient, and sometimes it is placed temporarily and then removed, depending on the type of treatment.
C is for computed tomography. My name is Dustin Lynch, and I'm at Memorial Sloan Kettering Cancer Center. A computed tomography, or CT scanner, is a special type of X-ray machine which rotates around a patient to obtain a cross-sectional image of the body. Most modern-day CT scanners consist of an X-ray source mounted on a circular ring or gantry opposite detectors. The patient lies on a table at the center of the gantry, and as it rotates, the source emits a fan-like beam of X-rays toward the detectors. By slowly moving the patient through a CT scanner, the computerized system can generate a series of consecutive image slices that can form a 3D image of the patient. Once a 3D image has been created, it's possible to view a cross-sectional image of the patient in any direction, making CT scanners a powerful tool for non-invasively imaging patient anatomy and identifying disease.
Hi, my name is Izabella Barreto, and I'm at the University of Florida. D is for dose. When radiation interacts with matter, it deposits energy. Radiation dose is the amount of energy deposited per unit mass of material. Medical physicists have a special unit for radiation dose, and it's called a gray, which is equal to 1 joule of energy per 1 kilogram of mass. The same amount of dose will not necessarily have the same effect on different parts of the body, because not all body parts are equally sensitive to radiation.
My name is Devin, and I'm at Johns Hopkins University. E is for electron. An electron is a subatomic particle. It has a negative charge, and it has a very small mass compared to other subatomic particles like protons and neutrons. Scientists figured out that electrons exist by doing experiments with glass tubes that had air removed, and then applying a voltage difference. Like other elementary particles, electrons can act like particles and like waves. After a lot of technical improvements, medical physicists today still use vacuum tubes to create radiographs to take pictures inside a person's body. With these tubes, electrons are sped up and crashed into a target to create X-rays that are used to image a patient.